Good afternoon, everyone. Thanks for joining our session, The Feature Who Loved Me, Arming the Frontline Fighters with Predictive Insights. Today, we'll be talking about risk modeling and some of the tricks and tips that we can share with you on how to build predictive risk models, pitfalls to avoid, and some of the frontline experience we have from our two experts today. My name is Spencer McLain. I'm VP and GM of EMEA for Ekata, which is a global identity verification provider that helps companies understand the risk behind phones, addresses, and emails. And today I'm joined by Elad and Craig. Elad, can you introduce yourself, please?
Sure. Thank you very much for having me here, Spencer. My name is Elad Cohen. I'm the VP of Data Science at Riskfield. Riskfield is the world's leading e-commerce fraud prevention company. We leverage cutting-edge technology, machine learning algorithms, and behavioral analytics to develop AI platforms that help e-commerce merchants outsmart e-commerce fraud and grow. We review hundreds of millions of transactions and have approved billions of dollars of revenue for merchants across virtually all industries, including Fortune 500 companies.
Hi guys, I'm Craig Savage, and they call me a Principal Data Science Solutions Architect, which is kind of very descriptive title. What it really means is my function is about helping our customers utilize the Ekata features within their models better, basically get the optimal performance out of our features in their models and get the most lift that they can.
Thanks, guys. And so this session will be kind of a Q&A. So I'm going to be leading a panel of sorts and asking our experts here some questions who will share some insights with you as the audience. And so first off, Elad, I've been working with Riskfield for a long time, over 5 years, visiting Tel Aviv, working with your team. It's safe to say that the Riskfield partnership is one of my most cherished partnerships across the company, and I'm not just saying that because you're on the session today. That's the truth. And you guys are honestly one of the most sophisticated data science organizations that I've ever collaborated with. And so, can you share with the audience, how you go about evaluating new features when you're building models?
Yeah, it's a really interesting process and one that we spend quite a bit of time on. So at the end of the day, you're trying to look at two different combinations. You want to have the domain expertise and the analytic insight into how a risk analyst, for example, would look at fraud and try to create a feature that can recreate that as much as possible. And then, of course, it's going to be coupled with statistical tests. So, Spencer, if you mind sharing, I've got an example of some of the things that we're looking at, and we have two different features here, for example. On the left side, we're seeing what we would look at as a good feature, and on the right side, we see a bad feature. So these are some of the plots that we create when we're doing different reports. One of the things that you're seeing, these balloon plots on the left that go from the green to red, is where we bin the feature value, and then we look at what was the target value. So in this case, as the feature value moves up for that feature, you're seeing that it's getting riskier and riskier. When we use different boosting algorithms, one of the things that we want to look for is that we have a monotonic function. So we want to make sure that it's very easy for the algorithm to understand that one side is necessarily riskier, the other side is safer. And in many cases, we're going to do different feature engineering in order to, or run transformations in order to get it more monotonic. So on the left side, left feature is really great. The right one, quite noisy, not that good, didn't make it into production. You also want to see a good separation. So we see density plots here between the approved population and the declined or should have been declined population. And the more the separation we can get for a feature, the more value it's going to be bringing in. And on the right side, as you can tell, not that much of a separation. So we're looking to have it monotonic. We also want to make sure that we have as little of a null rate as possible. And then finally, when we are ready to go, what we'll do is we will actually train a model with and without a feature, or with and without a set of features. We can measure what is the impact to the model at the end of the day, how much more accurate it's been able to get. We quantify that into an actual ROI, and then we can compare that. For example, if it's an enriched data source, like some of the features that we get from Ekata, we can actually see, okay, this is the cost, this is the value that we can get in lift, and we can run an ROI calculation. I'd say the last thing that's important in those cases, we always want to be sure that we're looking at the features as they would have been calculated in deal time. So we want to know what the model would have actually thought at that moment. And that's a really positive point with Ekata, where we can get what the features look like at the point of the order.
Great. Thanks for that, Elad. And moving on to another line of questioning. So Craig, as a solution architect, you work with dozens of different data science teams every quarter. How does your analytical approach differ from that of a typical data scientist?
Well, it's interesting hearing Elad talk and how they evaluate features. See, I go a little bit further, but that's probably easier for me because I've got less features to work with, right? So I can invest that time. I think like my input and my help to my customers is I come with all the context and the knowledge and the understanding of what's going on behind the scenes with our features. I've seen in lots of tests, I understand what's performance. I understand kind of how different features can be affected by different things. And like to give you like an example, I think the obvious thing when I was thinking about this before the call is that everyone's got a customer first seen field, right? Everyone probably has that. I'd say 99% of risk models out there have that somewhere in there. Now that gets impacted by geographic, demographic, different groups. You know, where that be that predominantly used to be in one region and then you've moved into a new region or new countries, or maybe you were selling a particular type of product before and now you're suddenly moving into something completely different. You know, that feature kind of has different strengths and different values. And what I do is I look, given the context of the Ekata features, I look to try and see how I can kind of help customers get more value from them. Now, let's think, if we think about something geographical, where you could supply, let's say that we're better in, we have seen more customers in Europe than we have perhaps in certain parts of Asia, then a model will kind of identify that, especially if you have a country field in there as one of the features. It will kind of pick up those different decision nodes. But what I'll try and do is try and establish where those relationships exist, and then how we can maybe better represent the feature to actually kind of take up less decision nodes. Because a lot of what I'm trying to do is I'm trying to get that maximum value in a small amount of space. You know, we supply 15 features in one of our main products, but we're competing with a customer that's got 100, you know? So it's trying to say, okay, if this impact is getting impacted by this particular geographic or demographic thing, then how can that be represented as one node? I think I've got a slide that kind of talks about different kind of encodings. I mean, what we got here on the screens is a nice simple thing. Have we seen a customer before, not seen a customer before, a fraud rate? Now, depending on your algorithm, you might target encode it, or you might one-hot encode something like this, or you might have a categorical kind of friendly algorithm that will just take that in as a category. Now, if that changes, we go to the next slide. If this changes geographically, what I will look at is which is the best way to kind of encode that feature. So what we're looking at the screen on the left-hand side is that North America customer base, seen before, never seen before. And on the right, we have the APAC. And when you look at the fraud rate, you can still see there's value in this field across different geographies, but it's definitely stronger in North America, where we've seen a lot of customers before. And this is perfectly understandable and kind of be accepted. Now, some customers will just take a target encoding and kind of just do that straight and you represent it on that fraud rate, just represent it with a number. The problem that can come by going down this approach is that you kind of end up teaching your model basically to identify North American customers, because the fraud rate for both of those is higher than the other two. So I will look into things like, oh, can we do it as a fraud rate variance? So the variance to that subgroup of that fraud rate to kind of turn it into more of a numeric. Or, there's other things like weight of evidence, you can plot that in there. And that kind of gives the model a numeric representation of that feature and allows it to see those different kind of values and get that maximum value in one node. And then that frees up other nodes. Now, how I do a lot of this is I will build models only to the depth of 3 or 4. I will add in all those sort of demographic, geographic kind of features, and then look at the actual combination of decision nodes and see where the model picked up the value, and then I'll try and represent it.
You have anything to add to that, Elad? Because I can give my undata science opinion. But we can start with you. But if you don't have anything to add, I'll kick it off.
Right. I think it's a really interesting use case. I mean, as Craig mentioned earlier, it's a bit of a constraint that we don't necessarily share because we aren't as limited in terms of the number of end features that we want to have. So it's not necessarily something we invest in as much, but I can definitely see the value when you want to bring in as much of that information into a smaller subset of features.
I think most data scientists, like, we limit our algorithms by a depth or by the number of leaves or the leaf size. What I feel this value can kind of translate to the broader community is that kind of doing this, it still allows you to do those kind of things and limit it to stop the overfitting, but it just allows the next couple of features to kind of come into that, all those different decisions.
Mm-hmm.
Well, I can tell you both that, Ekata's mission is we want to provide consistent data in any country globally, and we're pretty good at that. But the reality is data just is different country by country, and these types of methodologies really help us when we have customers that use us, all across Europe or all across the world. Some of our customers use this in 160 different countries or more. This type of targeting coding really moves the needle, and it's just a good evolution that Ekata's taken and how we can better support our customers. We're really coming up that curve. There's been a really great discussion so far. I had something on false positives, but we're just going to table that because I want to jump to my last question, and I can stop sharing my screen, which is around explainability, right? Like, models are inherently kind of a black box. You put in some inputs and then some magic happens and then there's a recommendation, right? I know there's a lot more to it than that, but as a business person, that's kind of how it works in my head. And so, maybe Elad, you can start with us and kind of explain, how do you balance the need for explainability versus model performance? Can you speak to that a little bit?
Yeah, so I'd say if you go back a few years, explainability versus accuracy used to be a major trade-off between the two. So in some cases, explainability would limit the type of algorithm that you'd have to use. I mean, I could take the most crazy example where you do a linear or logistic regression, so you understand each of the coefficients and it's completely explainable, or a decision tree. And then to the other extreme, you might use neural nets and not have as much understanding. Over time, there's been a lot of different methodologies to get more advanced features still be explainable. For us specifically, I can break it down into two use cases. So from a business perspective, the thing that drives us the most is making the most accurate decisions so that we can improve as much good customers as possible. We also have a use case where we want to be able to explain the decisions to our merchants. And it is something that we invest in, but I would not err to choose an algorithm that is more explainable at the cost of accuracy. So it's definitely, for us, it's number one is accuracy. And given the algorithm and the choices that we make to get it as accurate as possible, what can we do to still make it explainable?
I think they're not the black box that we all like to pretend that they are. And that I think it's worthwhile investing time to kind of like drill into them a little bit and seeing kind of how models end up using our features. I'm not sure that like feature importance, split gain, chat values, those kind of things really kind of accurately portray what a model's doing. I think I often think of it like it's a genie. It's kind of making a wish. You're making a wish to it, but it takes us very factually. It will find value and find connections in things that we don't expect it to. And I think sometimes actually looking into those nodes, looking into all those trees and seeing how it's kind of using that feature can maybe, surprise us a little bit. And maybe that could be finding justified value, but we can maybe represent it in a better way sometimes.
Well, I'm sure we could go on for hours, honestly, on this stuff. And, I really appreciate both Elad and Craig lending their expertise in this session. Data science is a fascinating subject, and it just goes so deep. And so over the last 15 minutes, I hope you, as the audience, have enjoyed a brief introduction into how Ekata and Riskified thinks about data science. And if you want to learn more, reach out to us on LinkedIn or submit questions during the session, and we'll answer those while you're watching them. Thanks for your time.
Thank you very much.